So now we start with the 4 queens problem, where there is a 4 by 4 grid, which is a chessboard, and there are 4 columns: 1, 2, 3, and 4. Our job is to place one queen in each of the 4 columns such that they do not attack each other. There is not a single attacking pair. So queens are like the first queen should go to the first row, second queen should go to the second row, third queen should go to the third row, and fourth queen should go to the fourth row. But please understand, the queens, when they move, they can only move in their column. So that's important. So now we have placed the first queen in the first row, first column. So this is the first one. So once we have placed a queen here, we have this row and this column kind of out of commission. So we cannot put any other queen in there. So for the queen 2, our choices are this, this, and this. So what we can do, we can put the queen 2 here. So it's like, you have a starting state, and then you put queen 1, q1, equal to 1, let's say in the first column. Then you reach to a next state. Then you are checking, okay, I can put q2 in the column 2. But then when you go there, is it a feasible place? No, like we have this row and this column out. So similarly, this diagonal is also out, okay? So we cannot place anything here in these cells. So this is not a valid state. So then we will try from this, that can we go to q2 equal to 3, the third column. So q2 equal to 3 will be this case when we put q2 equal to 3, and we can see that there is no conflict. So this is an empty cell without any conflict. So we can put actually q2 equal to 3. So this is the correct state. Once we put q2 equal to the third column, then the the first 2 rows are out. Then the queen 3, where we can place. So you can see that this is out because of q1. Now this is out because of q2. This column is also out because of q1. This column is out because of q2. Okay. So what remains, that I can put it here or here, q3. But you already know that these are, diagonally, this places are not viable. So if I put a let's say q3 equal to 2, this state is not viable because this is on the diagonal line, right? This is on the diagonal line for q2. So this state is basically not viable. Then we come to this state where we try the other side of q2, okay, other diagonal. So but this diagonal is also basically not viable. So q3 cannot go there. So if q3 goes to let's say q3 equal to 4, that state is also not viable. So then what we do, we backtrack, okay? We say, okay, q3's position is not good, so I think it's a better idea. So we go back to q2 and then see, can we change the position of q2? See, earlier q2 was in the third column. Now we change the q2 to this fourth column. So when q2 is in the fourth column, so basically this is the next, so here q2 equal to 4. q2 equal to 4. And then when q2 is 4, then easily we can see that, this row is out, this row is out, this column is out, this column is out. and this diagonal is out for Q1, and for Q2 this diagonal is out. But this cell is empty, so Q3 can go there. So when we are here, Q3 can actually go to Q3 equal to 2. And this is a valid state. But once that is true, so can I put, so what remains for me, Q3, this row is gone, this column is gone. So, you see, can I put Q4 here? So that is one viable spot, but this is on the diagonal line for Q3. So if Q4 equal to 3, that is really not an acceptable state because it's on the diagonal line for Q3. So this is also not a viable state. So then what we do, we again go back and see that can we change the position of Q3. There is no other position of Q3. If you remember, Q3 cannot be on the below Q2 on the third column or fourth column because they are kind of on the line of Q1 and Q2. So then we try to go back to Q2's position, try to check is there any other place for Q2. No, Q2 have kind of checked all the positions. So then we need to kind of go back to Q1 and see where else we can put Q1. Initially Q1 was on the first row, first column. Then we can check, okay, let's put Q1 on the first row, second column. And then we try the other options like we did here, okay? So here you will see that this is a acceptable placement, okay, using this tree. So you see this is called backtracking, this option where we kind of go down using DFS, and then when we hit that we are violating the constraint, that means the queens are attacking each other, then we have to backtrack and try the other options like we were doing. So here this is a valid acceptable board position, and this is a mirror position of this one, and then you can see that this is also an acceptable non-attacking position. So this is a valid position for 4 queens problem. This is also a valid position. Similarly for 8 queen problem, there will be 96 different valid positions. So now here one thing I want to stress that for this particular backtracking problem, we are saying that the queens are added gradually one after the other. So initially the board is empty, okay, empty. But we gradually add the first one, then we see where to add the second one in that way. And this forms the tree structure. And if we go to the next slide, you will see this is a tree structure. This is basically that backtracking tree in a better way. It's an empty state. Then you start the queen in the first position, second position, third position, in that way. It's not BFS, it's DFS. So we kind of go down this way and then backtrack and come up. And this is the one, we try the queens in the different places, and we can create, and then we can find the solution when the queen is in the first queen is the second position, second queen is in the fourth column, third queen is the first column, and the fourth queen is in the third column. So this is one of the solutions. So this is a backtracking tree, and here we stop the n queens problem using backtracking.